Welcome back. Wow, I'm so excited. We're getting ready for the winter racing series at Die Hard RC, doing the carpet indoor action, and wanted to get back. I keep on promising you guys the ultimate stock racer video. Well, this is gonna finally be the start of that series. Super excited to bring this to you guys. One little preface, I really wanted to try to collect some data and talk about that. Unfortunately, I had a problem with my phone and I accidentally deleted that data. So I'm really annoyed that I can't show you guys the raw data, but I do remember a lot of it, so we'll talk about it and go from there. And I still think we're going to have a really productive video. So hope you guys enjoy it. This is my Team Associated B6.4 two-wheel drive buggy. And some initial observations when I built it, the stock bearings in the car, they're actually, AE used to, when they provided these cars, they would provide the bearings with grease in them. And one of the first things you could do to improve the performance of your car is to take the rubber seals out of them and spray with motor spray all the grease out of them and then oil them. But the stock bearings in the 6.4, they have already done that, which I thought was really cool. So they're actually pretty free from the start. And then the other observation with this new car is this fan position right here. If I turn it around, you guys can see it. It's really nice because when you put the body on, the fan is outside of the body, and so you can see there, it's outside of the body, and so it's getting a lot cooler air, and I noticed that makes a significant difference on the cooling of the motor just in the stock form. So some pretty cool stuff with the new car. If we talk about my car in particular, from the start, when I first built this car, I have the Trinity RevTech X Factor 17.5 turn motor, and this motor has been dyno tuned. So trying to get max power out of that. My battery is a Phantom 4400 mAh, and it's one of those ultra low center of gravity batteries, trying to get my weight down with this, particularly the CG down. The trade-off with this is it's a little bit lower mAh, so you have to be careful that you're not getting too low a voltage at the end of your runs, so you just have to watch that. Here I have, this is an older speed controller. It's a Miclon Max speed controller, and as what I will say is this guy is a little bit heavy compared to a stock spec speed control. The Max ESC without wires, it runs roughly about 45 grams, and if you compare that to an XR10, Hobbywing XR10 stock spec speed controller at about 28 grams, so I'm about 17 grams heavier than a stock spec speed control up here. And then I have a little shorty MKS HBL 575 SL servo here, and I mounted my transponder down here versus up on the top like the kit has set up. I just wanted to get it lower and had the room, so I mounted it there. And tuning for stock, it's all about hitting the magic number of 1,474 grams, which is the roar minimum weight. And, you know, if you wanted to do this just to impress your friends, it's actually pretty easy to do it with the stock car. On my car, I'm running a steel bulkhead and steel chassis weights. If you go to the aluminum bulkhead and remove all the chassis weights, that shaves 62 grams. And that would put me just a gram or two above the minimum. But the thing of it is, that's really just to impress your friends. And that's the idea of tuning for stock, is removing the weight at the right places. And doing what I just said there is actually absolutely all the wrong places to be removing weight. I would say maybe the only exception, because my speed controller is slightly heavy, removing this weight, I could do that and probably basically be where I would be with a stock spec speed controller. But aside from that, it's all the wrong weight. So what is the right weight? The right way to do this, I approach it two ways. The first, I want to remove all the weight that's rotational weight in this car. Actually, in the back here, in the drivetrain, you want to remove rotational weight first. And that's about optimizing the drivetrain so you can get maximum power. And then the second item is you want to remove all the weight that is up high. So like going from the steel to titanium turnbuckles, you could replace all the screws that are up high that are steel with titanium. This motor plate I've already done, going from the aluminum to magnesium. But yeah, you could just replacing any of the parts that are up high that are steel with titanium and or aluminum will reduce the weight up high. And then if you do happen to get your car where you're under the minimum weight, then you would add weight back under your battery, and you can use these brass weights that go under the battery, and you would add it right there. And the intent of that is this battery is right around where the center of gravity is, and so you would add weight at the center of gravity as low as possible, and that would have the least amount of effect on the handling of your car to put that weight back in. So anyway, that's the overall basics of it. And then I wanted to talk, so this car has a bunch of modifications to the drivetrain, and I wanted to show you guys that stuff and talk about it. So let's dive in deeper to what I've done to this car. All right, so if we put this car on the scales, I've got the corner scales here. It's this Sky RC Bluetooth scale system. And if we put the car on the scales, when I built this as the baseline, it was all the parts I mentioned. So the steel front bulkhead, the steel chassis weights. It also, in my baseline configuration, the differential, it was the stock diff, but I was running a 2-gear diff. I was also running a magnesium diff pen in that 2-gear configuration. That diff pen, actually, special thanks to Brood RC, my buddy Eddie. He hooked me up with some pre-production magnesium diff pens. And so I have a magnesium diff pen in that diff. So in my stock configuration, or I should say baseline configuration, I started out, I was at 1,538 grams. And I've come in, and you know, to do the weight the right way, it's pretty pricey. That's why a lot of people get mad when you call it stock racing. But anyway, to do it the right way, we'll go into the details, but I shaved off 14.6 grams of rotation, mainly rotational weight. And so my car right now, I'll show you guys a screenshot of the this readout on these scales, but my total car weight right now is 1,524 grams. And then again, if I had a more of a stock spec speed controller, I could shave another 17 grams off of that. So I'd be in the low 1,500s right now. So yeah, let's look at this rotational weight. All right, so the first thing that I did at the track, you know, this is the first time I've actually done all these mods back to back at the track. And I was wondering if, one, I could collect data to show that the performance was better, mainly around the areas of motor and speed control temperature. And two, I was wondering, could I actually feel any difference? And I didn't think I would be able to feel a difference, but I was actually truly shocked. The first thing that I changed out on this car was I went from the stock bearings to the RC Speed Secret ceramic bearings. And I changed that out in the whole car, the drivetrain and the wheels. And, you know, minimal weight reduction, it was 1.54 gram weight reduction swapping out the bearings. But these bearings are really free, like significantly freer even than the stock bearings without the grease. And when I drove the car, I instantly noticed the improvement in torque. And so if you do anything in these mods, I would recommend doing this bearings first. It was a significant impact. You probably wouldn't feel it if you do this at home and didn't run it back to back, but I'm telling you, you could feel a big difference with the bearing change. So that was the first thing I did. And at the end, I'll list all the things I changed in the weight deltas. I'll show you guys a table. So then the next thing that I did was we went into the gearbox, and I switched out the idler gear. I put in a shaved idler gear, and I also put in a magnesium idler pen in there. And so the idler gear shaved 0.73 grams, and then the idler pen was another 0.53 grams. And so we did that next. I wouldn't say that I could feel a difference, but you know, like all these little small things, they start to add up. And so after that, we swapped out the motor plate. The motor plate shaved another 4 grams, and you know, this is like higher weight on the car, so it's great to shave that weight off. And then the slipper plates, you can see, went to these magnesium. They're pretty cool. They kind of remind me of a stormtrooper look. But those slipper plates, they shaved another 2.74 grams. And it was, you know, I wanted to watch this because I was wondering that magnesium is slightly less conductive than aluminum, and I was curious to see if any motor temps changed when we did this. But like nothing significant in the data. Is what I'll tell you is the when we did the bearings, my motor temps dropped about 10 degrees Fahrenheit. And then when we did all the rest of this rotational weight, it was another roughly 5 to 10 degrees Fahrenheit reduction. And is what that amounted to is I was able to go from a 29 tooth pinion to a 31 tooth and hold the same temperatures that I was running from the start. So I went up 2 teeth on the pinion gear with no impact to temperature. So that's pretty significant. And I'm actually, right now, this motor is running, at least on that day, which it'll probably be maybe even a little bit cooler when we go indoors. But this motor was running at about 130 degrees Fahrenheit, which means I still have room to increase my pinion gear. And so we'll probably play with that a little more. If we look at the final things that I did here, is I added you can see here, the drive shafts. I added this. These are the mod design puck system, and I added that, and that was another 5 grams reduction in rotational weight. And so, as I mentioned before, a total of 14.6 grams. So I'm gonna, for maintenance on the year, I'm gonna actually tear into this car and do maintenance. And as I do it, I'll take some quick videos to show you guys what these internal parts look like. All right, so here we are back. I've torn into my gearbox here. And one thing I did forget to mention as well is I run the aluminum diff cover, which actually does add rotational weight. But I find the plastic diff cover, it's hard to get that to properly seal at times. And as opposed to messing around with that, I just always upgrade my cars to this aluminum diff cover. Anyway, that's that. I'll open this diff up so you guys can see what I'm doing with the 2-gear setup. I also want to talk a little bit about filling it with diff oil. If we look at the back of my car here, you can see that shaved gear. You can kind of see those little lips on the outside of the teeth. That's the thickness that the gear would normally be. And so yeah, this gear has been shaved down. And then also the magnesium idler shaft is in there. So you can see that. And then here are the mag slipper plates and motor plate. Again, all these magnesium parts are from Brood RC. You can find them on the internet. And then finally here, you can see these dog bones. They have the orange plastic pins on them. And this is the mod puck system. And so we have that on the car as well. So first time I've ever tried these. So we'll see how that goes. Some people don't like the mod puck system because it does change the binding of the drivetrain, and that can change the grip of the car. I'm not too concerned for carpet because there's generally already too much grip anyway. So I think for the carpet, these are a great application, but if you're running like a clay or a dirt track, then you could maybe reconsider these. So yeah, that's the main, looking at the inside of my car, the changes that I did. Let me tear into this diff and we'll talk about this one a little bit more. All right, here we are. We've got this diff taken apart, and this is what we've been doing to build these diffs. We've been sticking it on the scale here and hit and tear. And then we've been using 20K diff oil at 0.8 grams. So that's not a full diff. Just a 0.8 grams of diff oil. And essentially is what that does is it simulates a lighter oil. I went slightly over, but there's 0.84 grams. So you can see here, that's nowhere near full. So let me stick so then I'm running the 2-gear diff with this 20K. So you can see here, I got the Brood Racing magnesium pen. This is actually a pre-production pen, so not for sale yet, but I'm running that solid pen and 2 gears. If you guys want to try the 2-gear, you can run the plastic cross pen, just leave the gears off of it, or you can buy, like Team Associate, actually Brood makes solid aluminum and solid titanium pens. I'd recommend it to pick up that aluminum one from Brood. But you can also just run the plastic cross pen and leave the gears off of 2 sides. So yeah, that's kind of what it looks like. The level, it's a lot lower than full. And if you do run this setup, I would recommend that you check it more frequently, because the less amount of oil you have, the more you can kind of cook this oil, and it doesn't last as long. Anyway, that's what my diff looks like. And I'll put this back together and I'll put my car together, and then we'll just kind of wrap this video by talking about the next steps. All right, so we got the gearbox all back together. I took the shocks off. I'm just gonna rebuild those with oil, etc., for the indoor season. But to conclude this video, a quick summary. We did all the gearbox lightning stuff, except I could put a slipper eliminator on here, and then I also have these Exotech spur gears, which are quite a bit lighter. So that's the last really thing that I could do on this car to fully lighten the drivetrain. I want to play with the slipper a little more. I find the slippers are sometimes a little more forgiving when you land crooked, especially on high traction tracks. So I'm going to play with that slipper a little more. But at some point in the season, I'll probably give the eliminator a try. But all the mods we did, it lightened the car by 17 grams. Total car weight right now is sitting at 1524. We could shed another 17 by going to a lighter speed control. And moving forward, I'm going to start looking now at doing some titanium stuff up high to shed some more weight up high. But anyway, super excited to give this thing a try. And overall right now, I did, through my testing and lightening of all the drivetrain components, dropped about 15 to 20 degrees Fahrenheit on my running temps as well, which allowed me to gear up 2 teeth on the pinion. So I hope this helps you guys decide on the mods, and sheds a little light on the important things to do when you are shedding weight. Anyway, the next one on this ultimate stock car I'll do is that weight I talked about up high, and we'll talk about that some. But thanks for tuning in, and if you like this video, please like and subscribe.